In one of my other classes, we did slope-intercept first, and I said, okay, who in here would prefer to use point slope, and nobody did, so we just skip it. Are you all comfortable enough with slope-intercept that that's how you're going to do every problem? Because it's okay with me, it doesn't matter. I just want you to have options if you want options. Let's review this one more time. Let's say we want to write the equation of a line that contains the point 2, 3 and negative 4, 5. Okay, and we're going to go ahead and use slope-intercept form. So do you remember how that works? How do we start? Got to find the slope. And actually, no matter what method you're using, you're going to find the slope first. Little review here. How do we find the slope? We subtract our y's over subtract our x's, right? It doesn't matter what order we do it in, but they have to both be in the same order. So if I do 5 minus 3, I got to do negative 4 minus 2. So I end up with 2 over negative 6, which is negative 1/3. That's my slope. Okay, we talked about this yesterday, whatever day that was. What do we do next? We plug in the slope and a point. I'm going to use this point because it doesn't have any negatives. It's just easier for me. But you will get the same answer no matter which point you use. And you're plugging them in up here. So your y is 3. Your slope is negative 1/3. Your x is 2. And I don't know my b. So 3 equals negative 2/3 plus b. Are you okay with that? Everybody remember how to multiply those fractions? Now I'm going to add 2/3. Three plus 2/3. 11/3. Very good. So b equals 11/3. For those of you that are a little bit foggy on that, this is 3 over 1, which is 9/3. 9/3 plus 2/3 is the 11/3. So your answer is y equals negative 1/3 x plus 11/3. Now, if you found 2 points out in the hallway and you had to write the equation of the line, how many of you would do it this way? This is your favorite way. This is how you do it. Raise your hand. So some of you would do it another way. How would you do it?
I usually just do point slope and then I change it to that.
Bingo. So point slope, we'll review it. But again, Mrs. Ford and nobody from here on out in your life is ever going to say use point slope form or use slope intercept form. Now, it might say write your answer a certain way. So write your answer in slope intercept form. But how you do it is completely up to you. So if this is you, tune me out for a moment. I'm not going to say that very often, but you can tune me out for a moment while we go through point slope, because you don't have to do it both ways. Point slope says y minus your y coordinate equals m times x minus your x coordinate. Now I'm using the same point. I could use either one. But I take y minus my y coordinate equals negative 1/3 x minus my x coordinate. The actual formula, for those of you that like formulas, looks like this. That's called the point slope formula. Now notice, we're going to end up with the same answer that we got before, because when I distribute and add 3, I end up with doing basically the same arithmetic and getting 11/3. Hence, it makes no difference which way you do it. It's whatever you're most comfortable with, whatever you can do most efficiently. that's what you want to do. Okay, so we're going to try one more, and you do it however you want. You do it your own way, but I want you to write the equation of the line through these 2 points. 1, 4, and -3, 8. Write the equation of the line through those 2 points, doing whatever method makes you happiest. And I did it both ways, so regardless of how you do it, you can check your work with mine and see how it came out. Anybody have a question about something up there? Everybody get that answer? Okay. Let's look on page of your textbook. I lost my paper, but I think I remember. Page 30, no, 41. Page 41, number 48.
Actually, it's a.
Page 41, number 48. And everybody find it. All right, how are we going to do that? What's your thought on that? Read the problem. This isn't summer reading. You have to actually read the question, okay? All right, so we read it. Find the slope of this section of the highway. What do you think? It kind of tells you in the problem. What does it say? It tells you what the rise is, or it calls it a vertical change, but that would be rise. And it tells you the horizontal change. So how are you going to build the slope? Rise over run. So your slope is going to be what? 6 over 100. So we can say 6 over 100, which is 0.06, or 3/50ths, whichever way you prefer to write it. Does everybody understand that's a real life application of slope? Rise over run. And when you're driving through the mountains, you'll see those signs all the time that say, 4% grade, next 8 miles, or something like that. And that means you're going up the mountain, or coming down the mountain. At 4 vertical feet for every 100 horizontal feet. All right, what about the next question? Okay, so the highway has a 6% grade. What is the horizontal distance required to climb 250 feet? So what horizontal would give you a vertical of 250? That's what the question is asking. You can do this a couple different ways. Do you have an idea, Miss Maya? So set up a proportion. And that proportion would be 6 over 100 equals, now what would the other proportion be? 250 over x. Somebody explain to me why she put correctly put the 250 on top. The 250 goes on top. She's exactly right. Why? Because it's the rise. It's the vertical. It tells me in the problem the vertical is 250. So when I set up my slope, it's vertical over horizontal. Now, we cross multiply and divide. Perfect. So I don't know what that equals, 4,000 and something. But what that means is you have to travel 4,000 feet horizontally in order to rise 250 feet vertically. All right, now you try C on your own. It's the same kind of thing. It does have one little tricky piece in it. I think you'll figure that out. Can you set it up the same way you set this one up? I mean, basically, fundamentally, can you set it up the same way? What did it look like when you set it up? 6 over 100 equals. $36,960. Okay, now I read the problem and I didn't see 36,960 in there anywhere. Where did that come from?
It's 7 times the amount of feet in a mile.
That the problem was given in miles, right? It said your horizontal is 7 miles, but the question is feet. So she changed that into feet so that when she cross multiplies and divides, her answer will come out in the right unit. So you should have gotten 369.6, is that right? Is my arithmetic right? Oh, no. I forgot the 6. What's that turn out to be?
221,760.
And so your answer ended up being 2217.60 feet? Everybody okay with that? Yeah. Oh, yeah.
What was the number on the bottom of this tab? Like 36,960.
What was that? Okay, in the original problem, the horizontal was a 7. Right? Didn't it say 7 miles?
Yes.
Okay, so I could go ahead and do that, Sam. So x is going to equal 0.42. If I work that out, x is going to be 0.42. But the unit on that 0.42 is miles. Because I put miles in here. This was miles. The question says, answer in feet. So I could go ahead and do it with the 7, but then I would have to take this number. Do you have a calculator?
Yeah.
All right, multiply 0.42 times 5,280, and you should get this same answer. Okay, 0.42 times 5,280.
2217.6.
Bingo. That's what she got. Because she changed the 7 miles into feet right away, just right off the bat. So then her problem wasn't in miles anymore, it was in feet, and she got this answer directly. Okay? You can do it either way, but you have to change your miles into feet at some point. Okay? Everybody okay with that? All right, now, next time we have class, which is tomorrow, everybody needs to bring a graphing calculator. We cannot finish P4 here without a graphing calculator. We got some stuff to do on the calculator. So you need to bring one. Now I understand you may not be able to rush out and buy it tonight because of time or money or some situation. Then you need to get your butt to the library. You need to check one out. Or you need to find a friend who will loan you the calculator this period. You gotta have one, because tomorrow that's gonna be our lesson, okay? We're gonna be pressing buttons all period, or most of the period. Okay? So I'm gonna skip a little bit of P4 now and jump into P5, because I didn't tell you how to have a calculator. I don't think I told you yesterday, and I should have. So, now we're gonna go to P5 and talk a little bit about equations that have squares in them. What do we call equations that have squares in them? Quadratics. So we're going to talk about solving quadratic equations. Now, what pops into your head? Let me throw one up here. How about let's say x squared minus 5x minus 7. All right, let's say minus 6. What pops into your head when I say solve this quadratic equation? One option you have is to factor it. And when you say factor it, you mean split it up into two parentheses, sort of unfoil it. Do the FOIL process in reverse. And find two factors that when you multiply them together, foiling them, will give you this. So I foiled in my head x squared plus x minus 6x. There's my negative 5 minus 6. I'm good to go. That's my factoring. Now, where do you go from here? If this is how you choose to do the problem, where do you go from here? Set them equal to 0, and x ends up being 6 or negative 1. Now, I hope that looks familiar to you because you've done it since you were about in 7th grade. Okay? The problem with factoring is, first of all, no matter how much we've practiced, some of us are really bad at it. Especially if we put a 2 or something out here in front. Oh! The other problem with factoring is it doesn't always work. Not everything is factorable. Remember when I had a 7 there to start with? That wasn't going to factor. So you don't even have it as an option sometimes. So if you can't factor or don't like to factor, what are your other options for solving quadratic equations? You could use the formula. Now, the formula works on every quadratic equation. But there are two things about it. First of all, your equation has to be set equal to 0. And secondly, you have to remember the formula. And what is the quadratic formula? The opposite of b.
Plus or minus the square root of b squared minus 4ac.
Bingo. There it is. And when we talk about a, b, and c, we're talking about the coefficients in the problem. So a is 1, b is negative 5, and c is negative 6. So I just plug in those numbers. So here we go. 5 plus or minus 25 minus 4 times 1 times negative 6 all over 2. 5 plus or minus the square root of, all right, now do this arithmetic, take your time, be careful. We're multiplying all this together and we get 24, which added to 25 gives you 49, which makes us really happy because it's a perfect square. So 5 plus or minus 7 over 2 So our answers will be 5 plus 7 over 2 and 5 minus 7 over 2. Does that look all right to everybody? Little hint. Maybe you know this already. If this works out to be a perfect square, the problem was factorable. So if you're ever struggling to get something factored and you're not sure if it factors or not, if you do the quadratic formula and you get a perfect square, it means your problem factored. Because your answers are going to turn out to be nice, neat numbers. If it's not factorable, you're going to get answers like this, right? That means that didn't factor. Obviously, the answers were hideous. It didn't factor. Okay. You have one more option to solve a quadratic equation. Do you remember what that option is? It's really important for future use for us. Not necessarily so important at this moment, but for future use, we have to know how to do it. Do you remember? Completing the square. Now, I'll be real honest. If I find a quadratic equation in the hallway, I am not completing the square. It is not my favorite. I don't like doing it, but it's a necessary thing. So we're going to go through the process because we have to know how to do it when we get to our hyperbolas and all that stuff. So step 1, move that number to the other side. You want to have just your x's together on one side of the equation. Now, do you remember what comes next? Now that I'm kind of jogging your memory?
Times the middle by 2.
Well, we don't times the middle by 2. We actually do the opposite of
But
that.
divide it and square.
Yeah, we're going to add something to both sides. And to figure out what I'm going to add to both sides, I take half of this. So that would be 5 halves, right? Half of 5, 1 half times 5 is 5 halves. And I square it. So to figure out what you're going to add on both sides, you take half of b and you square it. Now earlier today, somebody got kind of upset because I used 5 instead of -5. Does it matter ultimately? No, because you're always going to be squaring. So I just ignore the negative. Technically it is -5 halves squared, which is 25 fourths. This is why I hate completing the square. Now we call it completing the square because if you've done it right, this will be a perfect square. What is the perfect square? What's going to be inside those parentheses? X minus 5 halves. Perfect. X minus 5 halves. The square root of this, the square root of that, and that sign right there. X minus 5 halves. Beautiful. Equals, get a common denominator and add those. And we get, this is 24 fourths. And that's 49 fourths. Now we can square root both sides. And here's the part we don't dare forget. When we square root over here, the square root of 49 fourths is plus or minus 7 halves. Quadratic equations have 2 answers. In order to get 2 answers, you've got to remember the plus or minus when you square root. It's built into the formula. You get 2 factors. It's all taken care of here, but when you're using this method, you've got to do plus or minus. What happens to the square root and the squared? they cancel, they're inverses of each other. So x minus 5 halves equals plus or minus 7 halves. So x equals 5 halves plus 7 halves and 5 halves minus 7 halves. What's 5 halves plus 7 halves? 12 halves, which is 6. 5 halves minus 7 halves is negative 2 halves, which is negative 1. And now I've done the problem 3 times, and luckily gotten the same answer every time, right? Everybody okay with that? All right, I'm going to give you one. I want you to do it on your own using whatever method you like. So you got this one, or that one. Whichever one you like, let's do this equation. With the formula and completing a square, I could not factor it. It doesn't factor, so that wasn't an option for me. But I did it both ways. I want to notice I got the same answer, of course. But I'm going to talk about a couple of things. First of all, I didn't plan carefully enough, and I ended up with an imaginary root. Do you remember when you have the square root of a negative? The square root of negative 1 is I. Do you remember that from last year? So that I comes out, and then I have the square root of 24, which is 2 root 6, because I wrote 24 down. So it was 2 root 6. Now, here to here is something I want to caution you about. You are not always allowed to cancel. A lot of times kids will see something like this and they'll want to cancel the 2 and the 4. You cannot, because of that plus sign. In order to cancel, you have to be able to cancel all 3 positions. All 3 pieces of the problem have to cancel. I was allowed to do it here because all of these cancel. 2 goes into 4 and 2 goes into 2. You would never cancel 2 into 6 because the 2 is outside of the radical and the 6 is inside. You can't cancel outsides and insides. You can cancel 2 outsides and you can cancel 2 insides. If they're both under the radical, you can cancel, but you can't cancel outside the radical with inside the radical. All right, anybody have a question about that? Lee's got a couple homework questions I'm going to get to here. So Does anybody have a question about that? All right, well, we'll the next time we, when we're done with our calculator stuff, we'll practice another one and move on from there then. Good. Leah, we are not done. I need everybody paying attention to these questions and maybe looking through your own notebook and seeing what questions you have. I need to know section number, that's P1, P2, whatever, and problem number.
Okay, P1, number 53.
53 and P1. So we want the federal, oh, I know what happened. I know what happened. This is a tricky problem. Very tricky. I don't know why they do this. It's so tricky. You, in the table, for federal, they gave you 36,930,338. But did you look carefully at like the key? It says amount in thousands. So it is that many thousands. So technically, actually, there are 3 more zeros on here in terms of an actual dollar value. So when you put it in scientific notation, you're gonna have a bigger exponent than you thought. Does that make
I
sense?
think it's 10. I got 10.
Yes,
Yep.
that makes sense because this adds on 3 more.
Right.
Okay. All right. That's a great question. That is a tricky problem. Anybody else find a question? Still in P1, number 29. The interval from -3 to 4. And it says convert to an inequality. So this describes all of the numbers bigger than -3, less than or equal to 4. If you graphed it on the number line, maybe it says graph, I don't know. If you did it on the number line, it would be open at -3 and closed at 4. Blakely, that better be math you're doing back there.
Yeah, I'm looking at the PDF.
Okay. Now, the rest of that problem I don't want you to worry about. It talks about whether the interval is bounded or unbounded and its type. Don't worry about that. Those are technicalities we're not gonna freak out about. You need to be able to take that interval, write it as an inequality, and draw a picture of it. If you can do that, you're good to go. Sam?
Number 31 on P2.
Okay, are we down on P1? All right, so now we're going to P2, and we're looking at number 31. You know what? Hang on to this till tomorrow, because it's going to be easier for us to do that on our calculator. So I'll show you how to do it on your calculator, and that will be easier. I forgot there were some of those in P2. There's a whole bunch of them in P4.
Can we do number 23 and P2?
P2 23 says find the midpoint of the line, so -9.3 and -9.3 and 10.6. Now, those are not coordinates, so I don't plot them out here like this. Those are just 2 numbers on the number line. And I want to know what's right in the middle of those 2 numbers. This would be the midpoint right here. What's right in the middle? Well, anytime I want the middle, I want the average. So how do I find an average?
Add them both together and divide.
I add them and divide by 2. So the average is going to be 10.6 plus -9.3 divided by 2, which is, oh my, is that 1.3 divided by 2?
Yes.
So that would be 0.65. So your midpoint is 0.65.
Number 36.
36. Percent increase. Oh, great question. Algebra 1. How do you find the percent of increase or the percent of decrease? Do you remember you did a ton of these? if the value was 80 and it went to 90, what is the percent of increase? Anybody remember? There's like a little formula for it. It's the change over the original. So percent increase or decrease is change over original. If it's going down, then it's obviously a percent decrease. If it's going up, it's an increase. So, which problem was this, number 36? Okay, what number did you use for 1996? We kind of have to estimate, so what did you say? But it's a little more than 140, so maybe we'll say 142,000. And what was it in the next year, which was 1987? 181,000, we'll go with that. Now, you're not going, I mean, we're all approximating, so not everybody's gonna have exactly the same answer. But we're saying it looks like it's going from about 142 to about 181. Okay, so the change would be 39. And the original is 142. It's always change over original. So whatever that is, that's going to be a decimal. Somebody do it for me real quick. 27.4. Well, 0.274 is what you got, which means it's about a 27.4% increase because it got bigger from beginning to end. Okay, so percent increase or decrease, change divided by original, always. Oh, it's time for one more. They got one more? These are great questions. God bless you guys that are doing these problems. I don't know about you guys that haven't started yet. You need to get busy.
I have a question about this in general. When should we have this done by?
You have to have that done by the time we're finished with P7.
Okay.
So we have started P5.
Right.
So it won't be before the end of next week.
Okay.
Oh, I should say that. This is only Wednesday. Maybe a week from now. Could be a week from now. Which one? P1 number 38. Quickly, the bell is going to ring or not ring. We don't do that anymore. But you know
I'm done
what I
with
mean.
P2.
38 says use the distributive property. So I'm just going to take C times both of those, Blakely. So it'd be YC minus X cubed C. It doesn't matter. Multiplication is commutative, so you could do it in either order. Okay, so for tomorrow, what do we have to make sure we have? A calculator. Also, tomorrow is picture day. I don't even know what your dress code is. They don't tell the teachers that sort of thing. So do you know what you're supposed to wear for pictures?
I don't
Maybe since
we
you're
have to
seniors,
know
care
seniors
for
don't have.
seniors, for the juniors care. And
This will look good. Look good, feel good.
what was the other thing I
Don't
was-
you
oh,
impress from?
good luck on summer reading. I can't imagine walking in and not having read the books. Sit down.
The other was great.
All right, see you tomorrow. Be safe, make good choices. No, honey, no. Thank you. You can watch a video. Oh, I gotta turn that off too. You can watch a video and make it up, no problem.
Thank you so much, Mrs. Gordon.
Can I take a picture of one of the document calculators?
You can.